In the boundless expanse of existence where time itself seems to dissolve, we embark on a journey to the very dawn of time, to that singular moment a billion years ago, when our universe flickered into being. Imagine, if you will, a realm of unimaginable density, a point of infinite potential. This is the realm of the singularity. Our universe, once confined to a size smaller than an atom, explodes into existence in a cataclysmic event. This is the story of the universe, a tale that began 13.8 billion years ago. From this inferno of creation, the universe begins its relentless expansion. Space stretches and cools, birthing light, matter, and fundamental forces. In fleeting moments, the universe undergoes rapid inflation. Within this cosmic maelstrom, the seeds of our universe are sown. From a sea of energy, particles begin to form. As the universe cools, particles combine to form the first atoms. These raw materials give rise to stars, galaxies, and life itself. Imagine a time when the universe was young, less than 1 million years old. A time before stars, before galaxies, before even the darkness we know as space had fully formed. In this era, the universe was a sea of energy and particles, a cosmic fog so dense that light itself could barely penetrate it. This glow, known as the cosmic microwave background radiation, is the oldest light in the universe. It's a faint whisper from a time long gone, a time when the universe was 1 billion times hotter and denser than it is today. Encoded in its subtle variations are the seeds of the structures we see today, the seeds of galaxies, stars, and even planets. For hundreds of millions of years, the universe remained shrouded in this cosmic fog. Gravity, the architect of the cosmos, began to slowly draw together the densest regions of this primordial soup. Within these pockets of matter, hydrogen and helium atoms, drawn together by their mutual attraction, began to collapse under their own weight. Temperatures soared as these clouds of gas contracted, creating regions of immense pressure and heat. Imagine a furnace more powerful than any star we know today. This is the moment the universe first ignited. These first stars were colossal, hundreds of times more massive than our own sun. They blazed with a ferocious intensity, burning through the cosmic fog and illuminating the universe for the first time. These stellar pioneers lived fast and died young, their lives measured in mere millions of years. In their fiery cores, these stars forged the elements that would one day make up planets, oceans, and even life itself. Carbon, oxygen, nitrogen. The building blocks of our universe were forged in the hearts of these ancient stars. As these stars exploded as supernovae, they scattered these newly formed elements across the cosmos, enriching the interstellar medium and paving the way for a new generation of stars and galaxies. Drawn together by gravity's invisible hand, these stellar nurseries began to coalesce into vast cosmic structures. Galaxies, islands of billions of stars emerged from the darkness, their spiral arms and elliptical shapes tracing out the delicate interplay of gravity and motion. These galaxies, far from being randomly scattered, began to form a vast interconnected web. This cosmic web, with its intricate filaments and vast voids, is the largest structure in the known universe. And within its intricate embrace, the seeds of life scattered by those first stars would find fertile ground to take root and flourish. The brilliance of the first stars was fleeting. Their explosive deaths seeded the cosmos with the building blocks of life and ushered in an era of profound darkness. The universe plunged into a cosmic dark age. This was a darkness absolute, stretching across the vast expanse of the universe. Imagine a universe devoid of stars, where the only light comes from the faint afterglow of creation. Gravity works in silence, drawing together the scattered remnants. For hundreds of millions of years, this cosmic darkness reigned supreme. Unseen, untouched by the light that filled the early universe, a mysterious substance played a pivotal role in shaping the cosmos. We call it dark matter, a form of matter entirely unlike anything we can see or interact with directly. 5 times more abundant than the matter that makes up stars and planets, dark matter exerts a gravitational pull on its surroundings. Imagine a cosmic dance, a ballet of invisible partners. Dark matter, with its pervasive presence, sets the stage, its gravity pulling together vast clouds of hydrogen and helium gas. These clouds, drawn together by dark matter's invisible hand, begin to clump and cluster, forming the seeds of future galaxies. Within these vast clouds of gas, gravity continued its relentless work. As the clouds contracted, they began to spin, slowly at first, then faster and faster, like a spinning figure skater pulling in their arms. Imagine these vast clouds, millions of times the mass of our sun, swirling and churning in the darkness. The temperature at their cores soared as gravity pulled more and more gas inwards. These swirling clouds, these protogalaxies, would eventually give birth to billions of stars. As the universe expanded and cooled, the seeds of structure sown by dark matter began to take shape. The protogalaxies, drawn together by their mutual gravity, began to cluster and clump, forming the first galaxy clusters. Imagine a universe coming alive with light, not the blinding light, but the gentle glow of countless stars igniting within these newly formed galaxies. The age of darkness was coming to an end. The universe, once shrouded in shadow, was about to be illuminated by a billion suns. Within the cold, dark expanse of the early universe, gravity continued to draw together vast clouds of hydrogen and helium gas. These clouds, enriched with the remnants of the start moment, held the raw materials for a new generation of cosmic wonders. As gravity relentlessly compressed these clouds, their cores became increasingly dense and hot, like furnaces stoked with primordial fire. Imagine a furnace more immense than any we can fathom, a crucible where temperatures and pressures reach unimaginable extremes. Deep within these collapsing clouds, a critical threshold was crossed. The nuclei of hydrogen atoms, forced together under unimaginable pressure, began to fuse. This fusion, the very process that powers our own sun, released a torrent of energy, marking the birth of the first stars. These were not the stars we see dotting our night sky today. These were stellar giants, monsters in comparison to our own sun. Hundreds of times more massive and millions of times brighter, they blazed with a ferocious intensity, casting their brilliant light across the vast emptiness of space. Imagine a star so bright it could outshine an entire galaxy. These first stars were cosmic pioneers, their light piercing through the darkness that had shrouded the universe for eons. Their immense size and ferocious energy output meant they burned through their nuclear fuel at a prodigious rate. As these stellar giants neared the end of their lives, they became cauldrons of cosmic alchemy. Within their cores, the intense heat and pressure continued to forge heavier elements like carbon, oxygen, and nitrogen, the very building blocks of life as we know it. Imagine a cosmic dance of creation and destruction. And then, in a cataclysmic release of energy that dwarfed even their brilliant lives, these first stars exploded as supernovae. These explosions, visible across unimaginable distances, scattered the newly forged elements far and wide, seeding the interstellar medium with the raw materials for future generations of stars and planets. The death throes of the first stars marked a turning point in the evolution of the universe. The darkness that had reigned for millions of years began to lift, replaced by the soft glow of starlight and the ethereal beauty of nebulae. Vast clouds of gas and dust illuminated by the light of newborn stars. Imagine a universe teeming with possibility. The seeds of life sown in the hearts of dying stars, scattered across the cosmos, ready to take root and flourish. The universe, once a cold, dark void, was now a place of light, energy, and the potential for complexity. The stage was set for the emergence of galaxies, solar systems, and ultimately life itself. As the first stars illuminated the universe, they revealed a cosmos far grander and more intricate than previously imagined. Scattered across the vast expanse of space, like islands in a cosmic sea, were the faint glimmers of countless galaxies. These were not merely random collections of stars, but vast swirling structures, each a universe unto itself. Imagine, if you will, a universe not of emptiness, but of unimaginable abundance. A universe where billions upon billions of stars gather together, bound by gravity's invisible hand. These galaxies, formed from the swirling clouds of gas enriched by the first stars, took on a variety of shapes and sizes. Some, like our own Milky Way, formed majestic spiral arms, their disks ablaze with the light of newborn stars. As astronomers peered deeper into the universe, they began to notice something remarkable. The galaxies were not scattered randomly across space, as one might expect if the start moment had been a uniform explosion. Instead, they seemed to be arranged in a vast, interconnected network, like a cosmic web spun from threads of light. Imagine a web more intricate than any spider could spin, a web stretching across billions of light years, connecting the farthest reaches of the cosmos. This cosmic web, as it came to be known, is one of the largest structures in the known universe. The cosmic web is not a static structure. It is constantly evolving, shaped by the interplay of gravity and the expansion of the universe. Galaxies, drawn together by their mutual gravitational attraction, move along the filaments of the web, like beads sliding along a string. Imagine a cosmic dance, a graceful ballet of galaxies swirling and merging across the vast expanse of space. As galaxies move along these filaments, they often encounter one another. Sometimes these encounters are fleeting, a brief gravitational tug that alters their trajectories. The study of galaxies and the cosmic web has revolutionized our understanding of the universe. It has revealed a cosmos far more complex and interconnected than we ever imagined. And it has given us a glimpse into the processes that shaped our own galaxy, the Milky Way, and ultimately our place within it. Imagine, if you will, standing on a distant planet, gazing up at the night sky. Instead of a few thousand stars, imagine seeing billions upon billions, each a sun like our own, many orbited by planets, perhaps even planets teeming with life. The universe, once a cold, dark void, had become a tapestry of galaxies, each a testament to the power of gravity and the endless dance of matter and energy. The universe, once a cauldron of fire and fury, had begun to settle into a rhythm, a cosmic dance of creation and destruction. Galaxies, those islands of light in the vast cosmic sea, became nurseries for a new chapter. Within these swirling galaxies, the seeds of life found fertile ground to take root. These clouds, known as protoplanetary disks, were the birthplaces of planets. Drawn together by gravity, particles began to clump and collide, growing larger and larger. But the formation of planets was only the first step. For life to emerge, a delicate balance of conditions was required. The right kind of star providing a steady source of energy, not too hot, not too cold. The right distance from that star, allowing for the presence of liquid water and the right mix of elements. Imagine a planet bathed in the gentle warmth of its sun, its surface adorned with shimmering oceans teeming with the potential for life. The ingredients for life, forged in the hearts of dying stars scattered across the cosmos, were now coming together. We've traced the story of the universe from its fiery birth to the formation of cosmic structures. The universe's story is the story of the Creator's mastery, a story worth contemplating. We have come to the close of our story for today, but our journey has only just begun. Join us in our next episode as we explore the formation of Earth, a tiny world in the vast cosmos.